Auzubillahi minash-shaytanir-rajim. Bismillahirrahmanirrahim. Good morning, dear students of class 12th. Be ready. We will study about the solenoid and magnetic field inside a solenoid. You see solenoid, it is a helix-shaped coil, and when current passes through it, the magnetic field resembles the magnetic field of a power magnet. Within the solenoid, the lines are parallel, so field is uniform. Within the solenoid, that we call it inside the solenoid, the magnetic field is it is uniform, except at the edges we may take all the lines as uniform, whereas outside the field cancels and it is nearly equal to zero, or it is negligible. You see few lines, and this solenoid, its length is very large as compared to its radius. So now to find its field, let us consider a solenoid, and let us take a Amperian loop A, B, C, D. We apply here again Ampere's circuit law. To apply Ampere and find the field within the field, we take point P inside the, and around that point we make a rectangle path A, B, C, D. Let the total path of this be L. Let the total path be L, and B be the field within that uniform field. Now the length of path is L, so AB is equal to L. So number of turns, if N is the number of turns per unit length, then the number of turns within the solenoid enclosed within the Amperian path is equal to NL, and total current through the Amperian loop is equal to NIL, where I is the current through the solenoid. Now according to Ampere's law, integration of B dot dl is equal to mu naught NIL from A, B, C. So we can divide it into four parts. That is, from B dot dl, from A, integration from A to B, then it is B dot L, B to C, then B dot L, C to D, and B dot L, D to A. We take the integration from length AB, then BC, then CD, and DA. Now B dot direction of B magnetic field is towards left, whereas the direction of the loop current element BC and DA, they are perpendicular to B. BC is upwards and perpendicular to B, and DA is down and it is also perpendicular. So it will be B dot D, so it will be B90, so it is 0. So integration of second, that is B dot DL from B to C, and B dot DL D to A, they are equal to 0 because angle between them, field and DL is 0. The wire outside B dot DL at C to D, since this lies outside this part of the Amperian rule lies outside the field, so there is no current. So when current is 0, the integration it is B C dot, it is also at 0 because field outside the solenoid is practically negligible, so it can be taken. Now so we will get the integral of B dot dl around this Amperian rule ABCD is equal to integral B dot dl AB, while other three, they are equal to 0. As along the path AB, B and DL are along the same direction, the angle between B and DL is 0. Therefore, B dot DL is equal to B dot DL cos 0, that is B, and that is integral of DL. Now, DL is equal to length L. DL is angle L. So, integration of B dot DL along the Amperian rule ABCD is equal to BL. From the equation, that is from the this circuitous law, this BL is equal to mu naught NLI, that is current, that is total current threading through the Amperian law. So L and L cancel, we get B is equal to mu naught NI. It may be pointed here that in case of long cylinder, magnetic field is given by the above formula only at a point which is well inside the solenoid. At point is near the ends, the magnetic field is given by half of it nearly. At the ends, it is 1 by 2 mu naught N. If solenoid is wound on a core of a material having relative permeability as mu r, then B is equal to mu naught mu r Ni. Well, mu naught mu r is equal to mu naught mu r, that is absolute permeability of the core. So in case of core, this coil is wound over the core of some material, then it is mu Ni. It is mu Ni. While for a hollow coil, that it is equal to mu naught. So that is for today. Thank you.